Today I'm going to show you how to solve word problems using fraction and decimal multiplication. Let's begin. Today we're going to follow these three rules. We're going to model the problem, we're going to calculate to solve and write a statement, and we're going to assess the solution for reasonableness. Let's start. The first problem says Andres completed a kilometer race in 13.5 minutes. His sister's time was 1.5 times longer than his time. How long did it take his sister to run the race? Let's follow the directions. First, let's draw. We know that Andres completed the race, the 1 kilometer race, in 13.5 minutes. We know that his sister's time was 1.5 times longer. We know it's 1.5 times longer. We want to know how long did it take his sister to run the race. So what we're trying to find is this entire tape diagram. So we know that Andres took 13.5 minutes and his sister took 1.5 times longer. So we're going to multiply by 1.5. Now either we need to change both of our numbers to fractions or both of our numbers to decimals, because we can't multiply a fraction times a decimal without changing them both to the same. So I have 13.5 times 1.5. I could also do 13.5 times 1.5. Either way I know how to do, so I'll show you both ways. We'll do the multiplication of decimals first. 5 times 5 is 25. 5 times 3 is 15, plus 2 is 17. 5 times 1 is 5, plus 1 is 6. Placeholder, 1 times 5 is 5, 1 times 3 is 3, 1 times 1 is 1. We add our partial products. Okay, now we have to take into account that we multiplied by 10 to get rid of this decimal, and we multiplied by 10 to get rid of this decimal, which means we need to divide our answer by 100. So the answer is 20 and 25 hundredths. Now if we did this with fractions, it would look a little different. We would have to do 13 times 1 is 13, and 13 times 1/2 is 13 halves. Then we'd have to do 1/2 times 1 is 1/2, and 1/2 times 1/2 is 1/4. Then we'd have to add up all of our partial products. So we've got 13 halves plus 1/2 is 14 halves, plus 1/4. Okay, we have to change to common denominators, so times 2 over 2. So we have 28 fourths plus 1/4 is 29 fourths. I'm going to move it over here so we can see better. Okay, we have to add that to our whole of 13 and 29 fourths. Let's convert and figure out what that is. I know that 4 times 7 is 28, and I get 1/4 left. Now 13 plus 7 and 1/4 is 20 and 1/4, which is equivalent to 20 and 25 hundredths. So his sister ran, our sentence would say, his sister ran the race in 20 and 25 hundredths minutes, or 20 and a quarter minutes. The next problem says that a clothing factory uses 1,275 and 2/10 meters of cloth a week to make shirts. How much cloth would they need to make 3 3/5 times as many shirts? So, again, we're going to draw. We know that they use 1,275 and 2/10 meters, and we know that they need to make 3 3/5 times. So we're going to do this, 3, and then here 3, and I'm just going to show you the remaining 2/5 right there, but we're not going to include that. I was trying to do it with dots and it won't let me, but we're going to focus on just the 3 and the 3/5. We need to know how much they would need to make 3 3/5 times as many shirts. I'm going to do this problem just a little differently than I did the last one to show you another way you could solve these problems. So we know that each of these units are 1,275 and 2/10. So I'm going to fill those in. Okay, and we know that this whole thing is 1,275 and 2/10, but we only need 3/5 of that. Okay, so I'm going to change 3/5 to a decimal, and then I'm going to multiply that decimal times this so that I can get how much 3/5 would be. When I change a fraction to a decimal, remember, you've got to make the decimal or the fraction go to 10, 100, or 1,000. So I'm going to change this one to 10 because I know 5 times 2 will give me 10, and 3 times 2 is 6. So 6/10, and I know that 6/10 looks like this. Now I can go ahead and multiply. 6 times 2 is 12. 6 times 5 is 30 plus 1 is 31. 6 times 7 is 42 plus 3 is 45. 6 times 2 is 12. 12 plus 4 is 16. 6 times 1 is 6 plus 1 is 7. Then I multiplied by 10. I multiplied by 10 again, so I have to divide by 100. So I have 765 and 12/100ths, which is 3/5 of that number. So now I've got to do 1,275 and 2/10 times the 3 units, 3 whole units, and then I'm going to add this number and this number. 3 times 2 is 6. 3 times 5 is 15. 3 times 7 is 21, plus 1 is 22. 3 times 2 is 6, plus 2 is 8. 3 times 1 is 3. And now I'm multiplied by 10, so I have to divide by 10. So I have 3,825 and 6/10. And I need to add that to 765, making sure I'm lining up my decimals, and 12/100ths. And I can put a 0 here since there's nothing in the hundredths place there. 2 plus 0 is 2. 6 plus 1 is 7. 5 plus 5 is 10. 6 plus 2 is 8, plus 1 is 9. 8 plus 7 is 15. 3 plus 1 is 4. And my decimal comes straight down into my answer, which is 4,590 and 72/100ths. So my sentence would say they would need 4,590 and 72/100ths meters of cloth. Cyril purchased a concert ticket for $56. The cost of the ticket was 4/5 the cost of his dinner. The cost of his hotel was 2.5 times as much as his ticket. How much did Cyril spend altogether for the concert ticket, hotel, and dinner? Let's draw. We know he has the ticket, the hotel, and dinner. So we're going to draw 3 different units. Now, the concert ticket was $56. That's what we know. So we're going to draw our unit to represent $56. The cost of the ticket was 4/5 as much as his cost of dinner. So let's think about that. Was dinner more than the ticket? Well, if the cost of the ticket was 4/5 the cost of his dinner, then we know that his dinner cost more. Okay, so we have the ticket cost 4 units and the dinner cost 5 units. The cost of the hotel was 2.5 times as much as the ticket. So if the ticket is 4 units, we have 2 whole and a half, which is 2 units, times as many as that ticket. So they want to know how much did he spend all together for all of these. So we're going to try to find all of these. Okay? So this one should be pretty simple because we know that it told us with the dinner that it was 4/5 the cost of his dinner, so we know that the ticket has 4 units. So we're going to do 56 divided by 4 to find out how much each unit is. Okay, so we know that each unit is 14. Okay, so each of these little units are 14. All we have to do is to figure out each of those. We'd have to figure out how many units are in each. So if we wanted to figure out this, we'd do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 units. Well, 14 times 10 is 140. So I know the hotel was $140. And the dinner was 14 times 1, 2, 3, 4, 5. So 14 times 5. 5 times 4 is 20. 5 times 1 is 5. Plus 2 is 7. So it's 70. Okay, so the dinner was $70, the hotel was $140, and the ticket was $56. So all we have to do is add those together, 140, 56, and 70. And we get $266. So Cyril spent $266 altogether. And some of you might be saying, hold the phone. Can't I just add up each of these units all together and then multiply 14? Absolutely. So if you count 4, 10 plus 5 is 19 units. If you did 19 times 14, you would also get $266. Either way you decide to do these types of problems is totally up to you. I'm going to help you set up the drawing for this problem, and then I'm going to send you off to complete it. It says there are 3/4 as many boys as girls in a class of 5th graders. If there are 35 students in the class, how many are girls? So we have girls and we have boys. We know boys, there are 3/4 as many as girls. So there are 3/4 boys, and that means there's 4/4 girls. So we know that there are 35 students in the class. I'd like you to finish this problem and check for reasonableness and bring this in tomorrow. Thanks.